Hi everyone. Today we're going to be making tertiary butyl chloride in our lab. Um, t-butyl chloride or tertiary butyl chloride or 2-methyl 2-chloropropane, it all means the same. And we've already shown you a video on how to synthesize one bromobutane from one butanol. That was SN2. And today we're going to be doing a SN1 mechanism where, if you all remember the SN1 mechanism from your lecture, that you generate a carbocation, and it's a two-step process. First, you will generate the carbocation where the OH group reacts with the proton from the acid, and then you generate H2O plus, which comes off, leaving you with a carbocation. And then the Cl minus attacks the same side where the OH group came from, so it's called a same side attack, and you don't have an inversion in configuration, contrary to SN2 where you have an inversion of configuration. So if you started with an R isomer, you will end up with an S, and S means you'll end up with an R. And whereas with SN1, you end up with retention of configuration. So if you start with an R isomer, you end up with an R. If you start with an S, you end with an S. All right, that's the foundation of an SN1 mechanism. And this lab is pretty simple. There's not a ton of chemicals, there's not a ton of procedural work, but simple doesn't always mean it's fast. Okay, it doesn't mean you can finish the lab in 2 minutes. I don't think you can finish any organic lab in 2 minutes, but just to be clear, simple does not mean the lab will be fast. Okay, it would take its whatever time it takes. Okay, I don't want to give a time frame yet because it varies from how people do their routine. And if you follow what's described in the procedure that's given in the handout or the video, you should follow one or the other. You can follow both if you wish, but if you follow one or the other and you do things the way it's described, then it should take the regular time that it suggests it should take. Now, if you try to do shortcuts and think you're going to finish the lab faster, well, I'm going to give you the bad news. You're not going to finish it faster. With that said, there is a key to success on this particular lab, and that is, how good are you controlling temperature? It's not hard. So when you set up your mantle with the rheostat and you adjust the temperature, now you don't ever want to start with a 40 or 50 for this. Keep in mind that the t-butyl chloride that we're distillating boils between 49 and 52. So you have that narrow window. So you want to set your rheostat around 20, 22, somewhere in that ballpark. And you want to do a slow heating. You're not just cranking the temperature thinking I'm going to get to 49 really quick. Well, problem is it's going to shoot past 52 and you will be distillating stuff you don't want. So you don't want to go too high on the rheostat. Probably 20 would be better place to start. If you see it's not heating up as you would think, then maybe go a little higher, maybe 25. Don't go 20 increase. And that's the secret to success on this lab, because you want the thermometer, the temperature of the thermometer, to go slowly one at a time. So when you get to 49, you can collect the waste that comes before 49 degrees Celsius into a beaker or whatever you're using, and then switch to a different glassware, maybe a flask or a measuring cylinder, whatever you're using to collect. Get that in under the distillation end, and you collect the product between 59 and 42. Now it's easy, but if you try to speed up the reaction by cranking up the heat really quick, chances are you're going to be quickly going past 52, and you'd be at 80 or 90 degrees Celsius so quickly, well, basically you've lost all the t-butyl chloride. Don't ask me where it went, figure it out yourself. So the key to success on this lab, if you want to finish quickly but be efficient, then you need to not overheat the system too fast, too quick. Is that clear? All right. I'm going to stop the video here, and when I come back, I'm going to show you the reaction mechanism. It's probably something you already know, but it's a good practice to show the mechanism because we are doing organic chemistry. It's a good thing to know the mechanism. And then in the third clip, I will show you the reaction setup and what ingredients I have and what prior preparation I did before I actually started doing the equipment. So start doing the experiment. All right. Okay. With that said, I am a little bit over 5 minutes on this, so I'm going to stop right here and come back with the reaction mechanism. Okay. Now you can all see the SN1 mechanism that's shown on the screen. You've got 2-methyl-2-propanol on the far left hand side. It reacts with hydrochloric acid. You know how hydroxide and proton love each other, so they bond and then they make OH2 plus. Now that's a very unstable intermediate, so the plus comes off, which leads to a slightly more stable intermediate, and that is the formation of carbocation. And then you can see the nucleophile Cl minus attacking the carbon containing the positive charge, and it leads you to the formation of t-butyl chloride. So for just the synthesis part, we only need 2 chemicals. We will use additional chemicals as we try to extract and dry and purify the product. We use a couple of standard chemicals, but it's a pretty simple lab, not requiring 100 different ingredients going at 100 different times. So again, I can't repeat it. You cannot overheat thinking you're going to finish the lab faster. And if you do, well, you're going to have to start over again. There's no other way, and you just have to throw everything and clean all glasswares and start over. So your best bet would be to set it on 20, maybe 25. 20 would be a best place to start. And then if you see after 15 minutes nothing is happening, give it a little bit more heat. You just want good reflex. You don't want the liquid bumping all the way into the condenser, and that's not something you want. Okay, so this is a pretty simple lab. Simple doesn't mean fast, but it is simple in terms of what you're dealing with. All right, now when I come back, I'm going to walk you through the ingredients and the setup. Okay, here's the basic supplies you need, and let me walk you through what I have here. So here you have all the distillations kit over here, and then I'm going to get the round bottom flask when I'm ready, and I got a separatory funnel because that's the first thing you need. And then here I have 12 milliliters of t-butyl alcohol or 2-methyl-2-propanol, 12 milliliters there. And then I have an ice bath here, and I put some ice and water and put a measuring cylinder with 35 milliliters of hydrochloric acid, and it's been sitting there till the temperature of the bath got to about 5 degrees. It doesn't have to be super accurate. If you go a little bit lower, that's okay. The point here is you're trying to keep the hydrochloric acid a little bit colder when you mix it with the t-butanol. And I got some clamps, a thermometer. I'm going to collect my distillate in the measuring cylinder because I don't have a flask that's clean enough to collect the distillate. So that one's really clean, so I'm going to use that. And then that's pretty much it. And when I'm all set and done, I'm going to show you the next video. But the first step, you can go ahead and set up the distillation apparatus. But we are going to first do something with the separatory funnel before we actually do the distillation. All right, I'm going to come back with that. All right, I'm back with the first step in the procedure, which is I got an O-ring attached to an iron stand, and then I put the separatory funnel here. I got my stopper with me. So here's my 35 milliliters of hydrochloric acid that's been sitting in the ice bath. Currently it's at actually bingo 4 degrees, and the procedure calls for 5 degrees. So as I said, if you're a plus or minus 1 degree more or 2 degrees, it really is not, doesn't have to be that accurate. The goal here is we're trying to keep the hydrochloric acid cold because we will be adding propanol into it, and the reaction could get a little haywire. So I'm going to add all of this in one go, the hydrochloric acid. That's 35 milliliters of 5 degrees cold hydrochloric acid. Get every last bit of the drop. Alright, so that's the hydrochloric acid. And here I got my 12 milliliters of t-butyl alcohol. You don't want to add all of this in one go, okay? Add a little bit, shake, flip the stopper upside down, vent, shake until you use all of it. And then after that, we're going to shake a little bit vigorously, release the air each time, and then we're going to let it stand for like 5 minutes until the two layers separate. So basically, we have our product at the end of the procedure, but it's not pure. It's contaminated with other things. So we'll be doing the distillation, and then we'll be doing the extraction after that. All right, I'm going to add it just a little bit. Okay, cap it off. Okay, holding the stopper, I'm going to shake it. See, hear that? So face it away from you or your lab partner. You don't want to be on their face. Okay, that's good. I'll probably go a little vigorous when I'm all set and done, but that is good enough. You're shaking it. Add a little bit more. Shake it. I must have a leak in my... Ooh, you see that? You gotta frequently vent. Don't shake for 5 minutes and then vent. It's probably gonna explode by then. And I'm doing it completely in this direction because I think my valve is slightly leaking. So I don't want to lose any more of the reactant mixture. So I'm just shaking. See, I'm frequently venting. I'm not just shaking it for a good long time. And that's it. So we're gonna seal it, put it back down. As you can see, it's not ideal. I would have some cleaning up to do after when I'm done here. So, well, I'm gonna stop here and I'm gonna continue doing this, and then I come back to you with what's happened. All right.